Hey everyone, welcome back. Today I want to talk more about test-driven development, or TDD. Now I know as mid-senior level engineers, you've probably used TDD to some extent, but today we'll go a bit deeper. We are not just covering the mechanics, we are breaking down the philosophy and why it's worth sticking with even when things get complex. So TDD is structured around this cycle: red, green, and refactor. It's a simple framework, but it has a powerful impact on how we approach development. Let's walk through each phase. First, we've got red. This is where we start by writing a test for the functionality we are about to implement. The reason we call it red is that since we haven't written any code yet, the test should fail. The failure highlights exactly what's missing. This is like a to-do list for our implementation. Then we move to green. Here we focus on get the test to pass by writing the minimum amount of code necessary. This isn't about getting it perfect yet. It's about getting the green light, the indicator, the functionality works as intended, even if it's basic for now. And then we get to refactor. Once the test is passing, it's our chance to go back and clean up. We improve structure, increase readability, optimize, and reduce any duplication we may have introduced. Refactoring lets us polish the code while it is safe. Our tests are our test guardrails. So how do we take these steps? Let's talk about the philosophy behind TDD and why it's not just a nice to have, but a practical approach that solves the real-world coding challenges. First, TDD isn't just about bug fixing, it's about bug prevention. Writing tests upfront forces us to define requirements and think through edge cases before we even touch the main code. It's proactive, not reactive. Second, TDD builds confidence. With each test, we are essentially creating a safety net. So when we refactor or add features, we can do it confidently, knowing the test will catch any unintended issues. Third, TDD works well with agile iterative development. Instead of biting up huge chunks at once, TDD encourages small incremental steps. This approach reduces risk and keeps development steady and predictable even with complex systems. Fourth, TDD leads to better design. Code written to be testable is usually cleaner and more modular. Decoupling code to make it test-friendly often makes the overall design more robust and maintainable. And lastly, TDD creates documentation by example. Each test doubles as a guide for what the code is supposed to do, showing exactly how each function and class should behave. So when new engineers join the team, or when we revisit the code 6 months later, we have a built-in map of how things are supposed to work. Alright, let's see this in action. In my previous video, you can see the red-green refactor process in real time. See how that works? It's all about building functionality piece by piece with immediate feedback. This approach not only saves time on debugging later, but also results in cleaner, more reliable code. Thanks for tuning in. If you found this breakdown useful, make sure to like and subscribe for more deep dives for best practices. And drop a comment. How has TDD worked for you in the past? Or what's been your biggest challenge with it? Let's keep the conversation going. Until next time, happy coding!